quick little wrap up of reviewing solving for quadratics. We had factoring, got it covered. We have completing the square, we got it covered. And we also have the quadratic equation. The quadratic equation, I want to put up here in a minute. It's kind of the brute force method. It always works. Not fun necessarily, not necessarily pretty, but it works. And so if you're going to write some program, software, use a quadratic equation. Don't try to factoring program. I'm going to come back to completing the square in a minute, so I haven't erased it. But quadratic equation, or the quadratic formula, negative b plus minus square root of b squared minus 4ac that's the quadratic formula or the quadratic equation. A, B, and C are these guys. A, B, and C. Rewrite your equation into standard form, plug the numbers in, and crank it out. Okay? But let's recap on the completing the square. So I'm going to erase this last little bit. I'm one step above this. X minus 5 squared equals 7. Okay. You'll see we started with this guy. This is the equivalence. These two are the same. Graphing this one's not as fun. Graphing this one's a lot easier. What if I wrote it like this? Hey, look at that. This sort of looks like this. So by completing the square, you can also get the vertex form. Okay, those two are hand in hand. Complete the square, you get vertex form. And that's what we looked at right here. So now if I want to graph this, I know that the vertex is at positive 5, negative 7. Plus 5, negative 7, somewhere down here. Something like that. It was what, 5 plus or minus square root of 7. So my line of symmetry is right here. And this is okay. Let's do one more completing the square. Flip the page. This last completing the square is kind of interesting, but we should be able to do it. So x squared minus 4x plus 1 equals negative 5. And you can try to factor this if you'd like. I'll tell you right now, it's not factorable. That's why I chose this one. So let's go ahead and complete the square. Open up this space. Divide by 2 and square it, so 4 divided by 2. Okay. Sorry, dog's getting a little hyper. So 4 divided by 2 squared is going to be 4. So I'm going to add 4 to both sides. X squared minus 4x plus 4 equals negative 2. X minus 2 squared equals negative 2. Remember, I want the roots, so I'm going to take the square root of both sides. Those cancel. X minus 2 equals plus or minus the square root of negative 2. Uh-oh. Uh-oh. Square root of negative 2. Try that on your calculator. What do you get? It will say domain error, possibly, or you can't have a negative square root. This is where we start to have a problem. Okay? So I'm going to back up a couple steps. I want to go back to this one. Oh, hold a second, let me do this. So x equals 2 plus or minus the square root of negative 2. So those are my roots. These are my roots. And this square root of negative 2 is kind of a funky one. This is what we are working up to, interpreting what this means. Let's go back a few steps to right here. I'm going to make this into vertex form. Okay, so x minus 2 squared equals negative 2. X, f of x equals x minus 2 squared plus 2. Looks something like that. So my roots, my vertex is at positive 2, positive 2. Negative is a positive, remember? It's backwards. Let's call it right there. And where does this cross? Crosses at 10. Okay. So look what we have here. My roots, I have roots, I just calculated them. But I don't cross the axis. I can draw the parabola. There's no sleight of the hand here. It's just pretty straightforward. We got the vertex form, we got the vertex. I graphed out the parabola, the spirit of it looks pretty good. I don't have any crossings, but I have the root. These roots are either complex or imaginary. Those words are kind of synonymous. So this one here has complex roots. That means no real roots. Or you could think of it as the parabola is floating up in space, either floating positive up here, or it could also be down here somewhere, but it's just, or over here, you know. So whatever it is, it just doesn't cross the axis. There are no real roots for this one. We are going to now embark on what to do with negative square roots. That's going to be the next discussion.